get into the Blackboard site for this course. And then we'll look at the Festo RS logic ladder diagrams. And then we'll look at the distribution, which is the one that's already been done. We're there yet? Okay. Now we explain subroutines. What's a subroutine? Well, basically it's a model that supports itself. So what we do on large PLC programs is what we do is we subdivide it to make it more manageable and make it easier to troubleshoot, make it easier to figure out. So big PLC programs and also robotic programs are written in subroutines. So what you do is you mainly have what we call a main loop, and this is going to be ladder 2 now. So ladder 2 has to be, for Allen Bradley, ladder 2 has to be the main loop. And you see all these jump subroutines. Now what we do on Allen Bradley is we assign, once you set up a new module, it gets a number. So we have ladder 2, then we have 3, 4, 5, 6. And so the way you call these subroutines on RS Logic is you give it the new number. And that would give it which file down at the bottom that you go and pick up. Does that make sense? Yes or no? Okay. Huh? Okay. So here it says first pass. Now what first pass is anything that we want to be initialized when you originally turn on the processor. This first scan, this would only be true for the first scan. And then from then on, it's no longer valid. That makes sense? Yes or no? So we're going to have to figure out how to do this with the Siemens PLC. Okay. The other thing we have is we have an emergency stop, which is input 13. But remember, on ours, remember Allen Bradley PLCs goes in words, right? And what's a word? 16-bit. Siemens PLCs goes in bytes. Okay. So what's byte? 8 bits. So the addresses goes in bytes, or the module numbers goes in bytes. So we're going to have to figure out how to go from a 13 over to something that's on our PLC, right? That makes sense. And how many inputs do we have on our PLC? Anybody remember? Without the module. That's 12, yeah. So we got 8, and then we got 6 more. I'm sorry. So we got 14, right? We got 14 inputs. Without the module. So what we're going to find out is all our inputs. I think we'll have to look and see. I think we can pick up on the actual PLC itself. The main purpose that we're going to use this guy is to pick up. We don't have enough outputs. How many outputs we have? Anybody remember? We got, let's see, we got 0 through 7, then we got 0 and 1 in the second byte. So we got 10. So we got 10 outputs, right? Are you okay? So first pass, we'll execute this subroutine, or if the E-stop button goes true, right? Everybody okay? This makes sense? Are we okay? Everybody got any problems? So this is what we call a conditional subroutine, which means this subroutine would only execute if certain conditions are true, right? Does that make sense? And then we get into rung 1, we call that an unconditional subroutine. So every time it scans the main menu, it's going to go to subroutine number 6. And then the next one, it's going to only go to subroutine. The next one, it's only going to go to subroutine if whatever S1 is, whatever S1 is. So, but what's S1? So this is where, I'm sorry, S2. What's S2? Stop button. So that would be the stop button on the front. How did you find that? It's in the comments, right? So here they didn't call it they didn't call it when they set up this symbol. They didn't call it. By the way, look at the symbol. It's actually underscore S2. It's what they use for the symbol. Then after this, we get into sensors. So if the stop button is pressed or is not pressed, it'll run this right here because it's normally closed, right? Does that make sense? Okay, so down here, what's B? I remember what the designator for B is. So 2B, 3B, 1B. What's B? Huh? No, that would be over here. So this is B3. That would be an internal relay. We're talking about symbols. So what's B the symbol for? We can talk about that in class. I think we did. I know we talked about it in troubleshooting. Some of y'all have had that class. So this is something we need to know, right? So A is A, we use A for, we use B for, we use M for. So when I look at the diagrams, I get over here, it says 1M1 and 1M, 1M1, 1M, so M means something. Huh? Huh? No, these are not motors. I'll have to learn that. So these are solenoids. M's are solenoids. Here I see 1B2, 1B1, 1B1. So B must mean something. What's B? Sensors. So anytime we see sensors, it's B, right? Are we okay? Of course, this is the electrical. A is something that takes energy and converts it into motion. No. Anything that takes energy and converts it into motion, and we're talking about true motion, like motors and cylinders and stuff like that, we call those things actuators. So every circuit usually controls an actuator. Does that make sense? Yes or no? So I need to put those. So A is for actuators. B is for a sensor somewhere, right? M is for solenoids. V is for V as in Victor. Let's see if I got somewhere. If I got this somewhere, I need to give this out because it's very important because we're going to see this. I think I've got. on Classica. So here we go. A, if I see A, it means it's for what? Actuator. D is for what? Sensor. H is for R. K is for M is for S is for D is for valve. Z is for pneumatic. Huh? No, this is standard. Yeah. So we could look at the Allen-Bradley prints. If we look at the fluid power prints, we're looking at the electrical prints. Some of these would be on the fluid power prints, right? So if we could look at the Amatro line and we can look at the Festo line, and it would be the same. So these are basically international designators that we use for different devices. I'll print this off and give it to y'all. So what they're going to do is inside our electrical diagram, anytime we see a B, we know that's from one of the sensors out there on the Festo line, right? That makes sense? And of course, what it does, it also tells us, somewhere it tells us up in the comments what that sensor actually is. So I'll put this on your, yeah, so here's the symbols. If we're looking at the electrical, I'd have to blow this up. So in ISO symbols, anytime you see a square, it usually indicates some type of stick. And then we have a little black dash up there. What is that? This guy right here. This means it's an inductive sensor. An inductive sensor is a sensor that senses metals. Then we have this. Got the little square with two sides. This is an ultrasonic sensor. What does an ultrasonic sensor sense? Anybody that's had that? Distance, right? This is one of the symbols for photoelectric sensors, and we got photoelectric sensors all over the Festo line. I mean, they're all over them. The Amatro line only uses two. It uses a parts present under the main magazine, and then it uses one over there to figure out to flip it over. Then these little, anytime we see this little trough like this, that means it's some type of magnetic sensor. So this would be a Hall effect sensor. So this senses the magnetic field. But Hall effect is 3 wires. Can y'all see the 3 wires? And this right here, this is a capacitive sensor. A capacitive sensor senses solids and liquids. It'll sense a lot of things. And then the next one is what we call a magnetic reed switch. So the difference between a Hall effect senses a magnetic field, but it's electronic, so it has to be powered up. That's why it's got 3 wires. So 1 and 3, your odd wires, these are going to be your power leads. 1 would be positive, 3 would be negative, and then these are DC, and 4 would be the actual signal wire. A Hall effect sense, a magnetic reed switch, this is technically, it senses a magnetic field, but it does it electromagnetically. It actually, the magnetic field actually closes the switch. And notice it's only got 2 wires. This is a symbol for what? Indicator light. So it's a lot like the one. This is a symbol. This is the symbol of a limit switch. Y'all know what a limit switch is, right? Everybody know that? Everybody okay on limit switch? So these are actually mechanical devices. These are your international symbols for normally open and normally closed switches. Whether they're double break or whatever, you'll see these used on PLCs a lot. This is a symbol of a this is a symbol of a directional control valve. So this is what makes it the valve right there, that little thing right there. This is actually the symbol we should use for a solenoid. A1, don't get that confused. That's the actual way they label the terminals on there. So this would be a solenoid actuated valve, and notice it only pushes it in one direction. So this would have a spring return on it. This would be a directional control valve. How do I know it's a valve? Because of that symbol right there. And this uses two solenoids. So not only does it push it in one direction, it also pushes it in the other. This is a momentary contact push button. This is a little different. This is a what? E-stop with a detent, which means what? What's the detent do? Stays in place, yeah. And this is a symbol for a relay coil. Now the problem we're going to have is we're going to have to differentiate between this, because a lot of draftsmen, when they draw the solenoid, they forget to put the little slash through it. International symbols, right? You understand? So these same symbols would be used in the diagrams for the Festo line. So that's what we're doing. So that one line inside that control diagram is controlling several different things, right? It's being controlled by several sensors, and I have no idea where my So this says 1B1, so this says the workpiece gripper, right? Swivel the drive magazine, eject the cylinder. So this is why your comments become very, very important. So we're going to use a lot of comments in our program. We'll use exactly the same symbols. These are what we're going to use for tags. So when we look at our tag chart, what we're going to do is we're going to have the outputs and inputs on our PLC, and then we're going to match that to a symbol. And we'll go ahead and set up our tag table, and from then on, I don't have to know addresses anymore. I can use what? I can use the tags if you enter them right. So this is still ladder 2, then it comes all the way down, and then so you can see basically most of what it does is just call what? Subroutine. Now auto, this is ladder 3, so we don't hit ladder 3 until all the way down here. So we hit ladder 3, and then that's going to be auto. This is the main program. And you can see this guy predominantly uses B3s, which is what? Internal coils, right? And these use latching and unlatching. Y'all understand latching and unlatching? So once you latch, it's going to stay latched until you do what? Until you unlatch it. That makes sense? Okay? So you can see this is basically just following the sequence. Just following the sequence. So this would be sequence, this would be 0, this would be another sequence, this would be another sequence, this would be another. We haven't generated a single output yet. We're just following through the line, right? Does that make sense? And then all your outputs are way down where. So the outputs on this one, we don't actually pick up the first output, true output, until we get down to, I ain't got there yet. Rung number, here we go. Rung number 20 on this one is where I see the first axle output. Instead of sealing in, instead of coming up and doing the sealing circuit, they're doing what we call latch and unlatch. And so they latch an output, and how long does it stay latched? Until it's unlatched. Does that make sense? If you took PLCs from me, I think we definitely went over this, and this is one of the main reasons, because this is used a lot. And then we start generating outputs to actually run the line. So most of this we'll have to figure out the way the Siemens uses latch and unlatch, right? Understand? We know the outputs are not going to be O's, they're going to be what? Yeah, outputs are going to be Q. Yeah, set reset on the Siemens. Then here's our emergency stop, and all they're going to do is just fill the outputs with zeros. That'll put the outputs into a known situation. So we're going to have to figure out how to do this with the Siemens PLCs. There's another one too. I think it's up in the first one that I went by. Yeah, we got to figure out how to do this guy. Let's see where I'm at. Right here. Yeah, these are one shots. One shot means every time it comes through, it scans, it does it one shot, and it's through. Okay. This says it's going to one shot on the horizon, so that means when the run goes true, it'll give you a one shot. And then we also have one shot falling, right, which means it would give you the one shot when the rung becomes false. This is going to give us one shot when the rung becomes what? True. I have to figure out how to do that with the Siemens. Haven't seen any more that we need to figure out how to do. All this stuff right here is pretty straightforward. Back here on the emergency stop, we're going to change this up. It uses cross-couple timers to cause the lights to flash. We're going to use the timing. We're going to use the timing bit. And I'll show y'all that and where you can pick that up in the Allen Bradley software. So we'll use that back here, and then now on the 500, every subroutine has to end with a what? Return, and that would cause it to go back where? To the program that called it. We can have what we call nested subroutines. This is when a subroutine calls a subroutine. So a nested subroutine, but it would always take it back to the subroutine that calls it until it hits the final return. So it keeps up with how to get back to where it came from. So this guy here doesn't use any nested subroutines. I don't think we have any. There's another one shot. So okay. Now all the other programs are very similar to this. What we'll do is we'll just go through the programs. We'll assign the tags. So what I've done is I've set up the tag table for this. This is on Blackboard. I think it's in the So the first thing we'll do is we'll come up before we even start the tag table is we'll come over here, and this will be the address for the Allen Bradley, and then this would be the addresses we used on the Siemens. So this is the tag table. So the first thing we'll do is we'll go through all the ladder, right? You understand that, and then we'll go ahead and assign our tags to the S7 So in the S7, they call their bit, they don't call their bit files or their internals, they don't call them Bs, they call them Ms. And then we'll show y'all how to set up this, which is the memory, which gives us what bit? They don't call it first pass. Allen Bradley calls it first pass. Siemens calls it first scan. First scan, which should be that first scan that it does when you originally apply power to the PLC, or if you reset it, you can reset it too. If you do a reset, this will be only executed once. And then here's our timing bits. These are a little easier to use than the Allen Bradley because this actually gives you the frequency. We'll show you how to set up these bits right here. So in the Allen Bradley software, you're given a B3 file. In the Siemens, what they're doing now is they're not assigning any memory. They only assign memory when you need it, right? You understand? So you are on the new PLCs, you control the memory. In the older PLCs, the application controlled the memory. So remember, Allen Bradley had counters, so you don't see any counters in here. So it wouldn't even create a data block until you asked for a lot, until you created your first counter. So we'll go back and look at that. So this is our tag table that we'll fill out. We'll do this first, which we'll start working on next for whichever section of the line that you're going to work on. We're going to do the next two sections or the next two modules after the distribution, right? Which will be the testing and then the process. We'll do those. So any questions? Everybody okay? You okay back here, Maurice? Okay. So what are we working on now? Just trying to wire it to the front panel, right? Okay, how are we doing on that? You have any questions you want to talk about on that? Okay, guys, let's go to